right, we're gonna try this again. I am gonna go fast through the video so that we can upload it quickly, so you might need to pause it. But I'm asking you to find the absolute maximum of the objective function here subject to this constraint. So the first thing you're gonna do is take your partial derivative with respect to x of f, okay? So if I take this partial derivative, that would be 2x. And I'll take the partial derivative with respect to y, which would be 2y. And that's how we start. Then we'll take the partial derivative, do the same thing with g. So we'll take the partial derivative with respect to x, which would be 2x plus y. And then we'll take the partial derivative with respect to y, which would be x plus 2y. Great. So you're just finding the partial derivatives with respect to x and y of f and g. And that's how it starts. And that's pretty easy. So that's this step. So then once you do that, you're going to set up an equation. So you're going to take the partial derivative with respect to x of f, and you're going to set that equal to lambda times the partial derivative with respect to of x of g. So 2x equals lambda times 2x plus y. Okay, you'll do the same thing with the other ones that aren't circled. So 2y would equal lambda times x plus 2y. Okay, so that gives you these two equations right here. Now, however you solve those is going to be your choice. They're not easy to solve. Sometimes they are, but this one is particularly not easy to solve. What the hint in this one would be is to subtract the two equations. You'll say, well, how do you know to subtract them? That's one of the tools in the toolbox. Sometimes you can add the two equations and they solve easily. Sometimes you can subtract the two equations. You can multiply through by something to cancel them. You just have to find a way that solves them. Some are easier than others. But the suggestion here is to take the two equations with the red bar and subtract them. So on the left side, I would get 2x minus 2y. And on the right side, of course, I would get that top lambda expression minus the bottom lambda expression. After that, I just distributed my lambdas through here and here as normal, here and here. And then I combine my like terms. So 2x minus 2 lambda would 2x minus 2y would equal lambda x minus lambda y. I factored out what I could. So 2xy minus lambda times x minus y equals 0. And then I solved those out. Erase this. There we go. So that gave me two equations, lambda, or two solutions. Lambda equals 2, and x equals y. So if x equals y, you're going to take that and plug it into the g function, the g constraint. Go back up there. So here's your g function right here. You're going to plug x equals y into that function. Okay, so when you do that, you get x, let me go up a little, x squared plus x times x, because y is x, plus x squared minus 4 equals 0. And you solve that out and you get plus or minus the square root of 4/3. Okay, so that's two separate values, positive 2 over square root of 3 and negative 2 over square root of 3. Remember that y equals x, so you can form your points by plugging those back in there. And so that you would have those 2 points. Let's see if I can scroll down again. 2 over square root of 3, 2 over square root of 3, negative 2 over square root of 3, negative 2 over square root of 3. Right, so then you have one other option, and that's what happens when lambda is 2. Now, when lambda is 2, I just plug back into the top equation, the f of x constraint, or f of x equation there. You can plug it into the g function, the partial with respect to x, the partial with respect to y. It doesn't matter, wherever you can solve it. I chose the top equation. So 2x would equal lambda's 2 times 2x plus y. So if you solve that out, you get that y equals negative x. So once you get that y equals negative x, you can plug that into your g function. And so if you solve it out, you get y equals positive or negative 2. So when y is positive 2, remember x is negative y, x would be negative 2. And then when y is negative 2, x would be 2. So then you have these 4 points, and what you're going to do is take those 4 points and plug them into your f function, because that's what you're trying to maximize. So if you plug the first one in, you get 14/3. Second one, you get 14/3. Then you get 10. Then you get 10. Your max, of course, is your high one, which is 10, and your min is your low one, 14/3. And that is how it would work.